Let's start with number 6, okay? In 2005, the population of the United States was about 296 million people. The annual rate of growth in the population is about 1%. Complete the following table showing the predicted population to the nearest million of the United States for the 6 years from 2006 to 2010. These are the years since 2005. So if it says 0, we know that that year had to be 2005 since no years have passed. So this is 2005, this is 2006, 2007, 2008, 2009, 2010. So we have those years established. And so what we want to know is we want to know the population. We can actually put in the equation and find the answer to that question. Let's see, complete the following table showing the predicted population to the nearest million in the United States from 2006 to 2010. And it tells us that it grows by 1%. So here we are. Y is equal to 296 is our initial value. And now we want to know how much it grows. It grows by 1%. And it says it's growth. So we add. So it's 1 plus 1%. So it's 1.01 to the x. So now what we can do is we can put that in the calculator, or we could plug in 0 the first time, and that's just going to be 296, because anything to the 0 power is 1, and 296 times 1 is 296. And then we're going to do this to the first power, and then multiply, and then the second power. So I actually use the table. Remember to go to the table. You do y equals, go to your y equals and put this in, and then do second graph. And when you do second graph and look at your table, check your values to see if you get, after 1 year, it should be 299 million, and then 302 million, and then 305 million, 308 million, and 311 million. Now for letter B, it says write a rule beginning with y equals that can be used to calculate the U.S. population estimates for any number of years. We already wrote the rule. To me, it's really easy to write the rule from what you're given up top, so I like to write the rule because the rule helps me a lot. So let's go ahead and write our rule. 296 times 1.01 to the x. Okay, estimate the population of the United States in 2030. So if we look at our table, 2005 is right here. So how many years from 2005 does it take to get to 2030? 25, good. So we're looking for what is y? When x is equal to 25. Alright? So when we look that up, what we can do is plug it in. If you like, y is equal to 296 times 1.01 to the 25th power. Or you could put this equation in and look for where x is 25, what is y. And if you look at number 6, it rounds to 380 million. Okay? Alright, so now let's go to number 7. For number 7, they actually want us to write an equation for these. These look like exponential growth. From what we're given, it's a little hard to tell your growth, but we can write a general equation. We can see that this crosses at about 0.2. So our initial value is 0.2. That's our A. Times B, we know it's growth, so it's 1 plus R to some x, okay? And right here, when I look at my graph, that looks like it crosses at about 2. And so y is equal to 2 times 1 plus R to the x. Again, you can tell it's growth by the shape of the graph. So you'll probably have more on your test. You won't just have where it's that, it'll probably be multiple choice, and you'll be able to tell a lot easier. So let's go to number 8. Richie Rich celebrates his birthday on June 1st. This year, his parents have given him his choice of gifts. He can choose one of the following options. Option 1, his parents will give him $500,000 on June 1st. So let me pop that problem down for you. That sounds really good, but let's compare it to option 2. Okay, so his parents will give him $500,000 on June 1st. That's option 1. Option 2, his parents will deposit $2 in a savings account on June 1st, and then each day they will double the amount in this account until the end of the month, okay? So on June 30th, Richie can have whatever money he has accumulated in the account. So we want to use the calculator to decide which option Richie should choose. So what we would want to do for number 8, we already know that option 1 is y is equal to $500,000. Because that's it. No growth, that's it. You get $500,000. But option 2, if we look at that, they're going to deposit $2, so that's our initial value, $2. Plus they're going to double it until June 30th. So what we have to do is see what he has left at that point. So the month, if you think about it, the month of June is 30 days. On day 0, he has nothing, initially, yes. Day 0, he has 2. So let me make a little table for you. So on day 0, they're going to put $2 in to begin with. And then you have all the other days of June until you get 29 days later, okay? Because there are 30 days total. So 29 days later, you're going to use 29 as your x. And when you calculate that, you'll get something on your calculator that looks like this. And you have a little e. That means times 10 to the 9th power. So what that number is, it means you take this 1, you put your 1, and you move your decimal 9 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's good money right there. Thousands, millions, billions, $1,070 million. That's good. So he actually makes over $1 billion if he waits. Okay. Let's go ahead to do number 9. That's the last problem that we're going to do. 9 is not too bad. For number 9, it might look a little weird, but it's pretty good if you look at it closely. Let me move it up. We have to decide which graph goes with each of those situations. So number 9 says, tables, graphs, and rules of linear and exponential functions have predictable patterns and relationships. Match each of the graphs below with the most appropriate rule. Then explain your reasoning. So, okay, we have y is equal to a times b to the x. That's going to be growth or decay. We know that. It's not linear because that's not the format. So it's saying b is greater than 1. That means it's over. We're growing. So it's going to go uphill, and it must be, very good, C, because this is growth, and it's exponential. We can tell by the formula. Now we have y is equal to a plus bx, where b is greater than 0. Well, they're telling us that we have a positive slope, because b represents your slope. So you have a line with a positive slope. Because remember, this is the same as y equals mx plus b. They just flipped some things around. Wherever x is indicates where you can find your slope. So they have chosen to use the letter b for their slope. So y is equal to a plus bx is a linear and it's a positive slope. So it must be this line right here, so it's D. And we know that because it's linear with a positive slope. B is greater than 0. Now we have y is equal to a times b to the x, where we have a, we have b is between 0 and 1. So if b is between 0 and 1, that means we experience decay, because we're multiplying by something that's less than 1. So now we're going to go downhill, but it's still exponential, so it has to be letter B. And we can tell by the form of the equation. Exponential. Okay. Because your number is less than 1, so it's not growing over 100%, it's going down. And the last one, y is equal to a plus bx, and here we have b is less than 0. We have a line with a negative slope, so it's got to go downhill, so it's a. It's because it's linear with a negative slope. And that's it. We don't need to do number 10. Number 10 is not one you need to be responsible for your test. If you'd like to do it with me sometime later, though, we definitely can. But for now, I would just like for you to understand numbers 1 through 9.